Welcome to Graph AI Conference Cloud session. My name is Shuo Yang. I'm the head of cloud in TigerGraph. In the past decades, I have been leading team to build public cloud services in different contexts. And it's honored to be here to present our cloud service with you. And my co-presenter is Vikram. Vikram, can you introduce yourself?
Thank you, Shuo. Hi, everyone. I am Vikram Vunduru. I am Startup Solutions Architect working here at Amazon Web Services. Here at AWS, I help customers with architecture review or design. I help them providing solutions to their roadmap items and also educate customers on AWS best practices. And I'm very excited to be a part of Graph Plus AI Summit. And thank you, Shuo.
In this talk, Vikram will first talk about AWS global infrastructure. And then he will talk about architect your SaaS application on AWS. And then I'm going to talk about how infinitely scale graph analysis with TigerGraph from an architecture point of view. And then I also talk about TigerGraph on AWS, how we provide service. And then lastly, we will talk about a demo and get your feedback.
Thank you, Shuo. All right, let's talk about AWS Global Cloud Infrastructure. With 15 plus years of experience and helping millions of customers, AWS has gained an unmatched experience, maturity, reliability, security, and performance. Internally, we say that there is no compression algorithm for experience, and that's because you can't learn certain lessons until you get different milestones in scale. Customers are utilizing AWS Global Cloud Infrastructure to build their global SaaS fault-tolerant applications on AWS Cloud. As of now, we have 81 availability zones within 25 regions, with announced plan of 21 more availability zones and 7 more regions. AWS has the largest and most vibrant community of customers and partners. With 10,000 software listings from 1,600 ISVs, AWS has formed the biggest ecosystems for marketplace. We take security as job zero at AWS. With 230 plus security and compliance features, AWS has architected to be the most flexible and secure cloud computing environment. AWS is innovating faster than anyone else. In the year 2020 itself, we have launched 200 plus service offerings with 2,757 new features and services. Periodic price reductions are a normal part of our business. We have reduced 107 times since our inception. We expect to continue to lower our prices this year and many years to come. I know that you are curious to know what features and services we offer. And I think this is a very busy slide, but the key takeaway here is that we really offer the broadest and greatest set of services. And we offer you more functionality within each of these services. Everything starts with global infrastructure, the regions, availability zones, and points of presence. We have the core services on which everything else is built on top of that foundation layer. We have different compute services, including virtual servers, container management service, and serverless computing. When we talk about compute, Amazon provides most powerful resizable cloud compute capacity in the form of Amazon EC2 instances, which are equivalent to the virtual servers on-prem. We have the most powerful GPU instances for machine learning. We have the largest in-memory instances for SAP and other enterprise workloads. And I wanted to tell you that we are the only cloud provider in the market who offer the choice of Intel, AMD, and ARM processors. When we talk about containers, we have ECS and EKS, which can run on either EC2 or they can also run on Amazon Fargate, which is a serverless offering which we provide. We have different storage options starting from SSD and high IOPS EBS volumes, NFS for Linux and Windows as EFS and FSX. And also we have high performance storage volumes, which are FSX for Lustre, widely used in ML use cases. We have the broadest section of purpose-built databases for all your application needs. With Amazon VPC, you can provision all the logically isolated section of your AWS cloud, where you can launch all your AWS resources in a virtual private network that you define. We have so many security tools and features for you to define the security and access control, data protection, infrastructure protection, and make sure all the detective controls are in place. AWS machine learning and data analytics has completely taken away all the heavy lifting from our customers. Startup ISVs widely use these services to build the ML use cases for their customers. Last but not least, customers are building every imaginable use case with Amazon Web Services. Let's look at how customers can architect their SaaS applications on AWS Cloud. We have a wide variety of services which customers can utilize to architect their SaaS applications on AWS Cloud. There are various architecture patterns possible based upon what kind of isolation they need, how much they want to spend on their infrastructure cost, and what is their HA and DR requirements. With the services provided by AWS, customers can build every imaginable SaaS application on the AWS cloud. Customers can directly use EC2 instances to build a SaaS application and can provide a secure isolation at VPC level. TigerGraph uses similar isolation approach to help their customers to get most secured infrastructure for their graph databases. We have many customers who has deployed their SaaS applications on EKS and has achieved isolation per namespace. Customers who want to pay per request utilized by their end customers, we have AWS Lambda, which is a serverless compute platform and can be used to build serverless SaaS applications on AWS Cloud. For tenant routing and authentication purposes, customers can use Route 53 and Amazon Cognito. AWS has the purpose-built databases which can be used for storing data related to shared services or can be used to storing the data from multiple tenants. With this, I will hand over the stage to Shuo.
Thank you, Vikram. Next, I'm going to talk about how TigerGraph scale graph analysis from its architecture perspective. So first of all, let's talk about how TigerGraph partitions its data. At its core, TigerGraph is a share-nothing MPP graph database engine. And it partitions data into units called segments. A segment is a unit of data that hold vertices and edges. When the computation engine needs to retrieve specific vertices and edges, it can quickly locate the corresponding segments and access the data and so that it can conduct the computation. So for example, in this diagram, vertices 1, 2, 3, 4, 5, 6, and edges starting from 1, 2, 3, 4, 5, 6 are located into one segment, as it shows. And when the computation engine needs to locate those vertices, it can quickly locate the segment so that it can do the computation. We just talked about the partition side of the engine. Next, let's talk about the replication. Replication is a mechanism for us to achieve the high availability of the cluster. At the top of this diagram, you see 3 data nodes, and each data node is representing a partition. And so this way, you can see we can infinitely scale the data size of our cluster. And at the bottom of this diagram, you can see we have a replica 1 of each partition, and we have replica 2 of each replication. In this way, if one replica for a particular partition goes down, it doesn't affect the query and the storage of the cluster. So that in this way, we achieve the high availability. We talked about how we shard the data, the partitioned data, and we talked about how we achieved the high availability of the data. Next, let's talk about how query starts. Query has 2 modes. One is called single server mode. This mode of query is good for queries that start from one single vertex or a small set of vertex. For example, vertex traversal is such kind of a query. And then we can use the query master to retrieve the related vertex and edges related to that computation. And we conduct that particular query inside query master. Next, let's talk about another query mode, which is a distributed query mode. This is called distributed query mode because the computation are executed in all the server in parallel. If the computation needs shuffle the data, they will communicate across the server themselves. In this mode, we can do queries such as you need to start from all the nodes or a large portion of the nodes. We just talked about the architecture of our graph database engine, and hopefully I give you a flavor at a very high level that TigerGraph can scale the graph analysis. Next, we talk about how we offer our services using AWS infrastructure. We offer the managed service on cloud. What we do is pretty straightforward. We provision our cluster into different availability zones so that we can increase our server availability. And then we put a load balancer in front of our cluster so that we can load balancing the query. And then from there, the customer can consume the ALB, application load balancer endpoint, so that they can conduct the query operations. And in this way, our customer does not need to manage the infrastructure itself. Instead, they focus their energy to write the right query and get the result from their data. Next, let's talk about end-to-end private link. For customers who need highly secured environment, they do not want their traffic travel through internet. And we heard the voice of such customers. We are working on the private link system so that our customer can connect to our managed service through private connections. In this way, their query and their packet are going to travel through private link into our managed service so that they achieve highly secured environment. We just talked about the service on cloud, and next, let's do live demo. First, let me log into the cloud system. And we enable the social login. Here, I'm using my registered email address to log into the system. And you can see I'm directed into the dashboard. I wanted this dashboard by itself shows how many clusters I'm having, what's the current balance in my account, all this important information. And then let me go to the solution. A solution is a cluster for TigerGraph on cloud. Let me create a new solution. And I'm going to do a COVID-19 analysis as an example. And the next, I'm going to use AWS. I'm going to use TGC4M16. I'm using North California. The disk size, leave it as is, partition as 1, and the replication factor as 1, which we just talked about in our slides. And then here, name my solution, I say lab demo. And my password, set up my password, the lab demo conference. Yeah, conference demo. Next. So this is before I submit and launch the cluster. This is the parameters. I have a chance to modify going back, but here I'm pretty satisfied with the current setup. Let me launch the cluster. Now let's wait to see what is going on. So you can see the lab demo cluster is waiting, and it's supposed to finish within 5 minutes. So now the cluster is ready. We can see the status here, right? Now we can see there are 4 different choices here. The first one is for us to go to different application. Graph Studio we will go through in this demo. And the net data is our monitoring application. We'll go through quickly. And the second one is we can start, stop, and terminate the cluster. When you stop your cluster, you won't be charged for the virtual machine. But after that, you can restart by clicking start, and then you can resume your cluster. And this one is GSQL access. We are going to skip that in this demo. And the last one is about a solution detail. Let's go to net data for a moment. And you can see here we have the CPU, workload, disk, consumption, everything here. Now, let's go to Graph Studio. Launch a Graph Studio, and let me use the password here. And here in this Graph Studio, this is the main space for the analyst to work on. And there is a global view, and there is a My Graph. I go to the My Graph, and I can see the schema. Remember, we used the COVID-19, and in the example application, the schema has already been designed. And you can see the infection case, province, country, everything, right? So this is the schema. And we can also map what file we want to upload to fill the specific field. For example, this pop data is used to fill the province node vertex. And then after that, we can say, we already mapped our data. We will say, hey, let's really load the data. Let me continue. Now the data is start loading. Well, we are waiting for the data loading. We can see here, this shows how much data has been loaded. You can see the curve showing the real-time information. Okay, next, you can have options to explore your graph. And you can also build your graph pattern, right? And also write your own query. So this is for a data scientist or whoever do the graph analysis to work on after you load your data. I hope you enjoyed the demo, and please sign up for our cloud trial account. You have $25 credit, and it's enough for you to play with our Graph Studio and get a flavor of TigerGraph. And if you enjoy it, please let us know. And if you have any question, please let us know. Thank you very much for attending our session, and we look forward to your feedbacks to our cloud product. Have a good day.